Okay, this is pre-cal lecture 7.8.2, which is using Cramer's rule in a 3x3 matrix. So let's say, I'm going to give you a chance to pause the video for just a second and write the problem down. Okay, so let's say you've got three systems of equations. X plus y minus z equals -2, 2x minus y plus z equals 0, and then x minus 2y plus 3z is equal to 1. So we have the x column, the y column, the z column, and then the constant column. So we're going to make, this time we're going to make up 4 3x3 matrices and get the determinants of them. All right, so first we need to make matrix D. Okay, so matrix D, you make a 3x3 matrix that includes the x, y, and z column, but not the c column. So we would have 1, 2, 1, 1, -1, -2, -1, 1, 3. Now, you can either use the diagonal method or you can use the row column method. For this problem, I'm going to use the row column method. So plus, minus, plus. So remember, in the row column method, we'll start with this 1, and then we're going to find the determinant of this little matrix here. So you cut out the row and the column of the top number. All right, so our determinant is going to be 1, right, times the determinant of this matrix. So -1 times 3 minus -1 times 3 minus 1 times -2. All right, and then we're going to subtract our top number 1, subtract 1 times, and our determinant comes from 2, 1, 1, 3. Okay, that matrix, 2, 1. Remember, we cross out this row, or excuse me, this column and this row. So we'd have 2 times 3 minus 1 times 1. And then plus, our last one is -1. So we have -1 here, and then our matrix, 2 by 2 matrix, is right here. So we'd have 2 times -2 minus -1 times 1. Okay, so that's going to be 1 times -3 plus 2, so that's -1, minus 1 times 6 minus 1, so 5, plus -1, -4 plus 1, -4 minus -1, so -4 plus 1 would be -3. So that's going to be -1 minus 5, -6 plus 3, -3. All right, so our D value is -3. Okay, so we need to remember that. Now I've got 3 more matrices to make, and I won't be able to fit all of those on the board. So I think you can see I'll make D sub x, and then I'll erase and get D sub y and D sub z. So let's go ahead. I'm going to go ahead and write up here, our matrix D is -3. Okay, matrix D sub x, okay, you're going to replace the x column with the c column. So -2, 0, 1. And then look right back up here and copy those down. 1, -1, -2, -1, 1, 3. Okay, I'm going to use that row column method. So we've got a plus, minus, plus. So we'd have -2 times -1 times 3 minus 1 times negative 2. Okay, so that's our first. Our second would have minus 1. And our matrix is going to be 0 times 3. 0 times 3 minus 1 times 1. And then plus negative 1. Okay, so I'm working with negative 1 now, so our matrix is this matrix, 0 times negative 2 minus negative 1 times 1. So that's going to be negative 2 times negative 3 plus 2. Negative 3 plus 2 would be negative 1. Minus 1. 0 minus 1 is negative 1. Plus negative 1. 0 plus 1. So 0 minus negative 1. 0 plus 1 is 1. So that's going to be 2 plus 1, which is 3, minus 1, which is 2. All right, double check, that is correct. All right, I'll give you just a second. If I was in the way while you're trying to copy all that down, you can pause the video. Okay, so d sub x is 2. So we're halfway done. So obviously I couldn't really give you a test filled with Cramer's rule 3x3 matrix problems. You'll probably just get one. Okay, let's get d sub y. Matrix d sub y. We're going to replace that middle column with the C column. So we have 1, 2, 1, negative 2, 0, 1, and then back to the Z column, negative 1, 1, 3. All right, plus, minus, plus. So we have 1 times 0 times 3 minus 1 times 1. And then we have minus negative 2, so that'd be plus 2. All right, minus negative 2 is going to be plus 2. The matrix is 2 times 3 minus 1 times 1. And then finally plus negative 1. And that matrix is 2 times 1 minus 0 times 1. All right, so that's going to be 0 minus 1, so 1 times negative 1, plus 2 times 6 minus 1 is 5, minus 1, 2 minus 0 is 2. So I've got negative 1 plus 10, that's 9, minus 2, that would be 7. Let me double check, make sure I did that math right. Yeah, I did. So d sub y is 7. So we need to get d sub z. All right, I'll put that matrix right here. Okay, so we're substituting the third column with C values. All right, so I've got 1, 2, 1, 1, negative 1, negative 2, and then negative 2, 0, 1. All right, let's get the determinant of that. So we have 1 times this matrix. That determinant. So it's going to be negative 1 times 1 minus 0 times negative 2. Okay, don't forget the plus, minus, plus. Then minus 1, 2 times 1 minus 0 times 1. And then plus negative 2. That matrix 2 times negative 2. minus negative 1 times 1. So we have 1 times negative 1 minus 0, that's negative 1, minus 1 times 2 minus 0, so that's 2, plus negative 2, negative 4 plus 1 is negative 3. Negative 1 minus 2, that's negative 3, plus 6 is 3. Let me double check that. Boom. So d sub z is 3. All right, I'll get out of the way if you need to pause the video. Okay, so let's finish this thing up. Now again, if you prefer to use the diagonal method like we learned in the previous section, totally fine. You get to pick whichever method you want. I kind of switch between the methods, which one I like the best. I think they're both about the same amount of work. All right, so let's finish this thing up. So we know that x is going to be d sub x over d. D sub x is 2. D is negative 3, so that's negative 2/3. Y is d sub y over d. D sub y is 7. D is negative 3, so that'd be negative 7/3. And then finally z is going to be d sub z over d. And that is 3 over negative 3, which is negative 1. So our solution is negative 2/3, negative 7/3, and negative 1. So, not such a bad way to do it. Obviously you could do the elimination method, and maybe that's faster for you. But you do need to learn Cramer's rule, and Cramer's rule is how computers solve these kind of equations. If you can imagine, if you have 14 equations and 14 unknowns, a computer is going to want a system, and this is the kind of system that'll make that work. There's a class in college called matrix algebra or linear algebra that you can take that will really go through a lot of these types of techniques to solve multiple equations with multiple unknowns. Let me go ahead and write down the answers to 4 and 5. So this is 7.8. Number 4 is negative 3, negative 2, 5. And number 5, the answer is 3, negative 1, 4. So make sure you show all your work on your homework, and make sure that you make some sort of mark on your paper on any problem that you struggle to get and you need me to work. This is the last pre-cal lecture of new material of the year. So this is it for new pre-cal material. The rest is getting ready for tests and reviewing for the final exam. All right, so good luck with that, and let me know if you have any questions through email. Sayonara.